welcome to the outer space at Glasgow Science Centre. Believe it or not, this 4-ton boulder that's the size of a car can actually be moved only using your hands. We can actually use this boulder to talk about the laws of motion, which were first described by Isaac Newton in the 17th century. So the first law describes that an object will not change its motion unless a force acts on it. So currently, our boulder is stationary, but if I act a force on it, or if I give it a push, our boulder will start to move. Now, eventually our boulder will come to a stop, meaning another force is acting on it to cause it to slow down. We call this slowing force friction. And this is when two objects come in contact with one another, causing each other to slow down. See, as our boulder turns, it's also causing friction with the pipe at the bottom. And as these two objects rub against each other, they will slow down, causing our boulder to come to a stop. The more friction you apply to an object, the faster it will slow down. See how much quicker our boulder comes to a stop if you hold your hands against it. So the second law of motion says that the force on an object is equal to its mass times acceleration. Well, what is that? Well, here I have a tiny metal desk toy, and if I apply a small force to it, we get an acceleration. This one, because it has such a small mass, accelerates pretty quickly. Our boulder, on the other hand, is much, much larger and therefore has a far greater mass. If I apply a similar amount of force, nothing's going to happen. So clearly, to get this to accelerate, I'm going to have to apply a far greater force. So the third and final law is that for every action, there is an equal and opposite reaction. So, if I was to push against our boulder in my roller skates, instead of the boulder going forwards, I'm going to be pushed backwards instead. To counteract this, I'm going to need to ditch these roller skates and put on my boots again to apply enough friction to the ground to allow me that when I push it, the boulder goes in the correct direction. So these laws of motion help us understand how things happen on Earth, and even help us understand natural phenomena like whirlpools. It doesn't just apply on Earth though. Astronauts actually use these laws to help them get into space. It's not too bad for a 4-ton boulder sitting on the banks of the cloud.